we are going to do the forces
Laws of
and Newton's law of motion, right?
okay.
So Newton's law of motion is for this, it is about force, right? Uh, what is a force? Actually, we cannot see the force. We can only see the effect of a force. Okay. So what are the effects that we can see? When you push or pull an object, then you can see this object here. Okay, you pull it or you push it, then you can see the trolley moving, or you can see the spring being stretched. So this is the effect of the force. Okay, so when the spring stretches or compresses, then there will be a force. Although you cannot see the force, you see the effect of the force on the spring. The state of the spring in the state of stretched or in the state of compressed, and that shows that there is a force there. So another example is that when you kick a ball or when you hit a ball with the tennis racket, then the ball actually compressed. Or when you squeeze your towel, a wet towel, you squeeze the wet towel, then the towel is actually compressed or squeezed or twisted. Then all this shows that there is a force. There is a force acting on the object. Now, other than looking at the object, the state of the object, there is also when the object is in motion. Now, all these cases that I've mentioned earlier, the the spring and so on, they may not be moving, right? Or you compress a balloon and so on, the balloon may not be moving. But what if the object is moving? How are we going to see that there is a force acting on this moving object? Now, if for a moving object, if it is acted upon by a force, then the object will either move faster, that means it will accelerate, or the object will move slower. Slower means decelerate. Okay, so in both cases, there is a force acting on it. Other than accelerating and decelerating, if an object moving in a straight line suddenly change its direction, let's say when it's moving straight, it turn to the left or turn to the right or up or down, there is a change in direction. If there is a change in direction of motion, that means there is a force acting on it. Okay, one more time. We cannot see the force, but we can see the effect of the force. The effect of the force on non-moving objects, stationary objects, like the spring, then you stretch it, then the spring is in the state of stretch, or when you compress the spring is in a state of compression. That means there is a force acting on it. Okay, or when you pull a rope, right? Even though you are not moving, just pulling like this, there is a force applied, right? Or you are pushing. Let's say I'm pushing against the wall, even though the wall is not moving, but I am actually applying a force against the wall. Okay. Now, other than applying the force on these stationary objects, we can also apply the force to change the shape of the object. So change the shape of the object, very easy. Balloon can easily change the shape, right? So you squeeze the balloon or you squeeze a towel, wet towel, then you can see the effect of the force, right? Or when the object is moving, right? When an object is moving, you apply a force to the object will move faster. So you see the object moving faster and faster, there is a force applied. Or the object is moving and you see the object moving slower and slower, actually there is a force applied in the opposite direction. That's why it's moving slower and slower. Okay, other than accelerating and decelerating, right? Now let's say an object is moving in a straight line. Suddenly, the object turn, right? Turn in a certain direction. So, by looking at the direction, the change in direction, we know that there is a force applied on this object. Okay, right. So so far, any question regarding the effect of the force on a moving object and on a non-moving object?
No question, sir.
No question. Okay, no question. Then we go on to Newton's law of motion. So there are actually three laws of motion, right? The Newton's first law of motion, second law of motion, and also the third law of motion. Right. Now, the first law of motion, there is no calculation involved. There is no formula, no calculation involved, right? So it is just a quantitative treatment. So this first law of motion is also known as the law of inertia. Now, what is inertia? So afterwards, I'm going to explain all these examples to you to know what is inertia, right? Especially if you you want to participate in sports and so on. All the objects that's moving or your body itself, when you're involving in a race, you have inertia, right? So you have to take into consideration inertia, right? Okay, right. What did the first law of motion say? This is not the original form. This is what I quote from the textbook, the first one. So can you read this first one here from the textbook?
It's not the nature of the object to stop once set in motion, but rather to continue in its original state of motion. A stationary object will remain stationary unless acted upon by net force.
Okay, right. Now the next one. An object moves with a velocity that is constant in magnitude and direction unless a non-zero net force acts on it. Okay. An object moves with a velocity that is constant magnitude and direction unless a non-zero force acts on it. Okay, right. Actually, there are two parts. Okay, or maybe I try to break it up into two parts. Okay, now what is said in the first part is that the law of motion, right? The law of motion. If an object is stationary, it is not moving. So according to this Newton's law of motion, the first law of motion, that it will remain stationary, right? Unless it is acted upon by a force. So that means a stationary object will always remain stationary. Of course, when it starts to move, okay. Now when it starts to move, that means there is a force acting on it, right? So this is the first law. Stationary will remain stationary. Now another part is, what about the object is already moving, right? So this part describes that if an object is moving at a constant velocity, right, it will remain like that, in that state. It will move with constant velocity unless it is acted upon by a force. So that means when the object is moving with constant velocity, actually there is no force or no net force acting on this body, right? So it's moving with constant velocity. Actually, there's no net force acting on it. Oh, okay, enough, right? It will continue to move in a straight line, right? Now, contrary to this moving in a straight line with constant velocity, there is no net force. Now, contrary to this, if it is not moving with a constant velocity, what do you expect? Is there a force acting on it? Yes, if it is moving faster and faster, then there's a force acting on it, or rather a net force acting on it. Now, do you know what is net force or not? Net force, N-E-T, net force. Net force means there are a few forces acting on this object. There are a few forces acting on this object. Let's say, for example, this is an object. there are a few forces acting on this object, one here and one here and one here and maybe one at the top and the bottom. So a few forces acting on it, but then you don't expect this object to move in this direction, move in this direction, move up and move down. No. Now these four forces acting on the object will produce a net force. Okay, so this net force is only in one direction. The four forces add together will produce a net force, and this net force will cause the object to move in a certain direction. Okay. Okay, right. So that is the net force, right? Where are we now? Okay. First one is, yes, I was talking about an object moving in a straight line with a constant velocity, then there is no net force. Now, other than this case, an object moving in a straight line with a constant velocity, the opposite of it will be moving in a straight line, maybe faster and faster or slower and slower. If that is the case, there is a net force acting on it. Okay. They say that if it is moving in a straight line with constant velocity, no net force. Now let's say now it is not moving in a straight line. It is turning here, turning there. Now, so if it's turning around, that means there is a net force acting on it. Okay. So that is the opposite of what they are talking about in the Newton's first law of motion, right? Okay, we look at the second one. An object moves with a velocity that is constant in magnitude and direction. Okay, so if an object moves like this, constant velocity, fixed direction, that means there's no net force acting on it. Number 3, the tendency of an object to continue its original state of motion is called inertia, right? Now, mass and inertia, they are different things, okay? Inertia has no units. Inertia has no units. We can feel that there is an inertia. We cannot measure the inertia. Unlike mass, mass is actually how much matter you have, how much matter there is, and it can be measured. It is measured in terms of kilogram. So mass you can measure. It is the quantity, the amount of thing that you have, right? So it can be measured in kilogram. Whereas inertia, no, it is just a tendency. You cannot measure the inertia. Okay, now the first law of motion is also known as the law of inertia. Well, they say if an object is moving with constant velocity, it will continue to move. What is it that causes it to continue to move is the inertia of the object. Okay, so we are going to talk about the inertia here. Another thing, they say if an object is stationary, it will remain stationary. It has the tendency to remain stationary, and that tendency to remain stationary is called the inertia of that object. Okay, so object is just the tendency of the object, very reluctant to move. When it is stationary, it's very reluctant to move. It has a tendency to remain stationary. That is the inertia of that object. Or if the object is moving, if it is moving, it has the tendency to continue to move. It cannot suddenly stop by itself. So it has the tendency, and that tendency is called inertia. That tendency is called inertia, and it is described in the Newton's first law of motion. Okay, now we look